Hi guys, it's been a long time. I put up a video out there, but I'm back. I'm better, and it's good to have you guys again, right? And on this call, on this video, I'm going to be talking about some optimization concept in data warehousing, which is going to include partitioning, indexing, and clustering. Let's get right onto it. So, I'm going to use a very much relatable concept in order to explain this. So imagine you are looking for a specific book in a library with millions of volumes, like a lot of books, but they are all thrown into like a massive room in no particular order. The books are just inside, no kind of order, no arrangement. It will take you days, to actually find what you need. Probably you're just looking for a book, uh, and you know the title of the book, you know the author, but then you just go inside the library and you have the books thrown all around the library. You are going to start, doing some full search. In the world of data warehousing, we call this a full table scan, which means that you have to go in there and start taking one book after the other until you find what you're looking for, right? Now, to fix this, we use three main tools: partitioning, indexing, and clustering. All right, let's break them down into uh, the library context here. The library context here. So now, this is the library, right? This is Ruben standing in front of the library, and you know, let's say we want to make Ruben lives easier in order to find its book. Now we're going to talk about first thing partitioning and how it relates to data warehousing. So I'm going to use the library as a context. So let's say we have different rooms, right? And these different rooms in the library are labeled, say, 1900, say, 2000, say, 2010s, 2020s, etc., etc. Right now, it's kind of much easier, you know. And these numbers are just probably the publishing date of that particular book. Now, it makes it a lot easier for you to, like, lower down your search if you know the date that the book was published. For instance, if the book was published like 2012, you know that you're going to go to this room to look for the book, right? So first off is partitioning. This is the process of splitting a massive table into smaller, more manageable pieces based on specific column, like a date or a region. In the context of our library, we are using uh, published date. So in our library, instead of one giant room, we split our books into different rooms based on the year of publication. And what's the benefit? If you come in asking for a book from 2015, I don't even need to open the doors to 90s, 2000s, and the likes. I just go to uh, the room of 2010s. I know that in that particular room, I will find the book I'm looking for. So we just have to ignore what we don't need, which saves us massive amount of time processing power in terms of data warehousing. So we call this called partition pruning. So it means that when Ruben goes in there, it doesn't need to go inside this room. This room will be X'd out. I don't need to go here and waste my time. I'll just go into this particular room to look for the book I'm looking for. That is partitioning, right? That's the first step. Now let's talk about indexing. Let's talk about indexing. Now, indexing in this case, now we are in the right room for the book that we're looking for, which we know that it's published in this particular day, right? But the room still has a lot of books, say thousands of them. Let's say you're looking for a book called The Great Gatsby by F. Scott Fitzgerald. Now, you could check every spine or you could use an index. Now, what's an index in this case? Like, you can can be like a catalog of books based on the author, right? So an index is a separate structure that maps a key like the book title to its physical location on the shelf. So in each room, there's probably like a shelf and sections in that shelf. So how does it work? You look up maybe like G in the catalog, which says Gatsby is in the room 1920, right? Aisle 4, shelf 2. Like, so the trade-off here is that while indexes make finding books incredibly fast, they take up extra space and require maintenance. And what does it mean? So think of index like a catalog or a metadata index like a catalog. So when you enter the right room where you can find your book, and there's going to be like a catalog that would say based on the title of the book you're looking for, right? So it can be based on title of the book. It can also be based on the author of the book. Now, this catalog will direct you which shelf and which section. So in this catalog, you find these details probably arranged in alphabetical order. It can tell you which shelf, which section the book is. Now, imagine that you have to go into a room that has thousands of books arranged in a shelf. You just have to go find the catalog and look for the title and author of that particular book, and it tells you which shelf to go to and the section of the shelf. The section of the shelf definitely is going to be numbered, right? So it can be section C10, something like that, right? So it makes it easier to find the book in the shelf. However, as I mentioned before, it takes space, right? And you have to maintain the catalog, right? Because if you add new book to the shelf, you have to update the book in this index. So index, in this catalog, which in this case index. So the index, while the index is taking space and it requires maintenance, it's worth that trade-off, right? Because in data warehousing concept, storage is cheap, while compute is expensive, right? So you want to trade off space for compute. So it's worth it for you to have your data warehouse catalog so that it's easier for you to find what you're looking for, which is going to reduce your processing time, that is your compute. So that's about indexing. Now let's talk about clustering. Now you now find your shelf. Let's say this is your shelf and is divided into sections. And let's say this is A1, A2, A3. This is B1, B2, B3. Then you have C1, C2, C3. Let's say this extends up to like dot 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 A10, B10, and C10. So imagine that you don't have this indexing and you have to start looking for the books from A1, then you get to A10, then you go to B1 to B10, then go from C1 to C10 before you see what you're looking for. But indexing has now streamlined your sets to just this place. Now, talking about clustering. So clustering now make you focus on C10. So you just come to C10. This is C10. So we want to talk about clustering. So as the word is, so finally we have clustering. While indexing is cheat sheet that tells you where things are, clustering determines how the data is actually physically stored on the disk. In this case, how the books are arranged in the shelf, right? So in the library context, we can decide to cluster by author's last name. So the last name of our author in this case is what's the author's last name? Our author's last name was Fitzgerald. So which starts from F. So typically, let's say our arrangement is A. This first row is A books. Any author that the last name starts with A. Then another arrangement is like B, then F, this way. So now it's just this clustering has streamlined your set to just books that are in this F section, like with author's last name as F. So you just come here and then start looking for the author's name for that particular book. So here you can then pick the book that you want. So probably the book that is going to be in this section will just be like 30 books. Imagine probably from the onset we have 1 million books. Let's say this the library was not partitioned, then you have to start from one book after the other before you see what you're looking for. So you have to scroll through over 1 million books. But now because of partition, instead of going through 1 million books, we know that our book was published in 2015. Then probably you go to section of 2010s of year of publication. Probably in 2010s we only have maybe 2,500 books published within this year. So it has streamlined your search from 1 million books to just 2,500 books. Now index, which tells you which section the books are, which is section C10. Out of these 2,500 books, this might just streamline your set to just 150. Now with clustering, you now streamline out of these 150 books, it will just be probably 20 of them that the author's last name starts with what? F. So we have been able to streamline our search from 1 million books to 20 books. And that is the essence of what? Of partitioning, indexing, and clustering, which is going to reduce our processing time a lot, uh, faster in that case. So instead of having to scan 1 million books, it will just scan 20 books. Now, be conscious that compute and processing time can look so fast under the hood because you are using computer to process it. But then it really matters when you do all these things in order to reduce compute or processing time. Now, because it is a computer that is doing it, you might not really see like the cost when you are scanning like 1,000,000 rows. But imagine that you are scaling and you're so imagine that you have to scan 50 million rows, but now you just need to scan 20 rows. Look at the time that you're going to be that is going to reduce compared to having to scan a full table. So that is why these three concepts is very important in data warehousing. And that will be the end of our discussion today. Don't forget to like, follow, subscribe to the channel, and so that you can get notification when we release similar videos like this. Have a wonderful day. Thank you.